Hi, I'm Justin, an engineer at Baseten, and I'm going to show you how to build an application around OpenAI's Whisper. Whisper is a general purpose speech recognition model, meaning that it can take on a lot of different tasks from speech data. So like things like translation, transcription in multiple different languages. So this open source model was published like just over a week ago. And we saw a lot of downstream implication of like having these models that are traditionally sort of exclusive to academics and the people that make them, being put open source and allowing the public to have like a free form on them, and try and better these models, implement these models, use these models. So we thought it would be a perfect application of the Baseten platform to sort of get this deployed and running in a actual app for end users. Um, so the usage is pretty simple. It's all detailed here. I guess what we were tasked with was packaging it up into a truss, which is Baseten's way of sort of packaging and pipelining models so that they are readily deployable on the Baseten tool. Yeah, so my job was just to get like this working model, this great work from the folks at OpenAI, and then get it onto our platform. Yeah, and that sort of started off with first defining a truss. The docs for that are in the truss implementation. And essentially, if you run something like truss init, and then give it a target directory, so let's say tester. In the command line, you will pop out with a truss. So with this, you can define different things for your model. So things like a data directory, if you have data that is used for inference for your model, the model itself. So things like the actual functions of the model, like how that's initialized, if you have to load in anything, pre-process, predict, post-process, as well as all of your requirements and a configuration for your actual model. So you get this sort of starter boilerplate template, and then you can go about building out the model and its implementation within this framework. So going through how exactly to do that with Whisper, we first want to take a look at the model.py file. And from here, it's really standard. So you're just defining your model object after it comes out of this packaged form. So things like specifying the data directory, the configuration, if you are making use of a GPU, as well as the model itself. So for the model that's going to be deployed on Baseten and available for a demo for different users and other interested folks, we chose to load in the small model. So Whisper has a bunch of different variations of their models, varying from as much as like 40 million parameters to over 1,000 million parameters. There's probably a better way to say that, but from here, yeah. So we're using the small multilingual model for our purposes. So we load that into our load function here. We can define a pre-processing step. So this was modified a little bit to interop with the new microphone component that Baseten came out with to interface with this model specifically. So this works by taking in a dictionary, parsing out a URL from that, writing a binary file with the content of this MP3, and then passing along a reference to that file path within our dictionary. Yeah, so Truss works by passing different dictionaries throughout this sort of pipeline of first initializing, then loading, pre-processing, and we go down to our predict function, and then finally our post-process function. So To move from preprocess to predict, we set up our response dictionary. We actually call the actual transcription from the Whisper model, specifying our file path, that MP3 that we got from that response. These are just different parameters that are specified for the actual transcription function. I chose the default presets if you were to use Whisper as it's intended in the command line. So yeah, they also have like a command line client, which is really cool. And then we get the response from that, getting the transcribed text from speech, as well as the detected language that we pick up from this inference. And then finally, we're doing some cleanup in our post-processing step, where we format this detected language in a nice string, as well as remove that file that we wrote to temporarily. So we're through with the model.py file. So we can go into further configuring our truss. So in the config YAML, these are all going to be auto-populated, sort of key value pairs. And you can fill in the corresponding configuration that you'd like for your model. So in particular, the ones that we want to look at are like the Python version. This is something that you should specify. In the Git repo, they let us know that the Python version that they use is 3.9. So we're just going to specify that here, as well as specify our Python requirements. So this is just a way to install the requirements listed in this Git repository. So if we go here, you can like pip install directly from here to look at that explicitly. It's all here. We are also installing a CUDA wheel for us to enable our inference on a GPU. So that's going to speed up our inference time and ultimately the user response time by a lot. And then the request to be able to grab the file from our S3 store so that we can perform inference on it. Here you can also specify your resources. So things like CPU, memory. This is a kind of large model, so allocate it a bit more. And then you want to set use GPU to true if you're able to utilize a GPU. Those are kind of the basics of our truss configuration. Again, the last thing is a system package. We use Ffmpeg for our audio processing. This is also a new sort of thing from, which version is it? Let's see, truss version. Yeah, so in truss 0.1.1, they introduce a new spec version. So it just allows for more flexible invocation of our predict function and doing stuff like that. Previously, we had to like have a more rigid input to our predict, as well as some like keys that we needed. But we kind of switched this up to allow for very flexible calls to this predict function. Awesome. So that's kind of it for the config file. You can put in like different examples here if you are doing this for like documentation purposes, or you expect other people to use this, and it's not so straightforward. For Whisper, we try and take that onus away from the user and just have a microphone in front of them, have a button that says, hey, use the model, and then we have the result right there for them. So not so necessary, but please fill this out if you think it's helpful. Yeah, so from there, we can actually use the Python client. This is just a notebook for like different testing of the model, making sure that it works to our specification and that we're satisfied with the results. And after doing that, really just want to key in on this cell. It's super, super simple to deploy a model from a truss to base 10. All we have to do is import the Python packages base 10 and truss, get a handle for our truss from the directory that we have our truss in. Log in with your API key. So this is something that you can do if you go into your user settings and grab that API key, which will establish a session for your user. And then you can go ahead and deploy your model with that truss handle and give it a name. So you can see here, we were able to deploy this model to Baseten. So because this model utilizes the GPU for inference, there's a couple of in-between steps that we have to take in order to make sure all of that works out. But the folks at Baseten can sort of help you with that if you have problems with that or need a GPU for your model. Yeah, Trust is open source. So if you feel particularly passionate about the sort of stuff that we're building or this sort of initiative, there's instructions for how to contribute. Yeah, if you want to contribute and push this project forward. We can go through this. So just to check our model and that sort of health status. So I went ahead and deployed this model and provisioned a GPU for it. So this is kind of behind the scenes work, but we know that it's okay. So we can go ahead and start to build out our application. So you would do this by creating an application, which would take you to the same thing that we're going to do here. Looking at what we have here, we have a view, a worklet, and some of our files. So the view is sort of the interface that we are going to work with in order to build out our front end for our application. So you can see on this side, we have a whole bunch of components that we can add by just clicking and dragging onto our view builder. So things like a heading, which we can go ahead and put in. Say whisper demo. And let's say we want to make this a little bigger, we can do so. We're going to kind of build out our application by clicking and dragging all of these different components. In particular, one that we're really interested in is the microphone component. Big shout out to all of the hard working engineers at Baseten. They were able to spin this up in like 2 days, 3 days for this demo specifically. So really good. So the way this works, and we'll show a little later, is you just click on this, record a snippet of audio, and that'll get pushed up to our public S3, which you can then query into this view builder to fill out whatever components that you have. Yeah, and then let's also add the button, because we like buttons, you know. Let's say transcribe. And what I'm going to do, just to be a bit defensive with how we build this app, I want to set this to be disabled to begin with. So the way we do that in Baseten, we can do by specifying the view itself. So if you see this is sort of highlighted, the entire page, we can add an event handler. So on load, I want to set a state. Let's say it's called button disabled. And let's set that to true. So when we load in this page, we are specifying a state for button disabled. If we load in again, we can look at this button disabled and see that that's true. So what we can do here is bind this to our state, and we'll see that this button is disabled. So we can't click on this. Awesome. So what we'll do here, we're going to add another event handler for our microphone to enable our button after we upload something. So let's set the state, button disabled, and let's set this to false here. So after we record something, we're going to be able to click on this button. And let's do a little bit of housekeeping for the outputs that we're going to get from our model. So here, we're going to put the detected language. And if you remember from our model.py file in our truss, which we can go back to, we have this sort of string already formatted for us. But for safekeeping and just for my reference as we're building out this app, I'm just going to put that there. And then here we're going to put the transcribed text. Okay, so I'm pretty satisfied with how this looks so far. There could be a little sprucing up to do, but we'll consider this a bare bones application for now. And what I want to do is, now that I have sort of defined what my front end is going to look like for V0, I want to sort of implement the logic behind it, as well as the model invocation. So let's look at our worklet here. We can even delete this. So this is what like a worklet looks like to begin with. It's just a DAG that specifies some sort of workflow for a particular worklet. So these worklets can be called or kind of triggered by different UI components in our view builder. So what we want to do eventually is have an event handler so that when we click our button, we can run a worklet, and we can run worklet 1. If you remember, we specified our model to take in a URL parameter, and we're going to bind this to the microphone component value. So again, we're going to be recording a section of our voice that's going to be uploaded to S3, and then we have a URL to that, and that's saved into the microphone.value field. So we'll be running this worklet and saving the output of that worklet to this state, worklet 1 output. So we'll use that later to fill in these text boxes with our model outputs. So going back to the worklet, we're going to add a model invocation block. We can select a model from our existing deployed models for our user. Let's select Whisper, and then you can just select the primary version, or if you have many version models, you can also select those. So we'll go ahead and stick with the primary version, which is 0.2. Yeah, and for this application, this is kind of all we need. We have all we need to fill out the components in our view builder, but if we wanted to add more business logic and sort of envelop this model invocation in that, you can add different Python functions that you can specify here. So we provide this main.py file for you. You can add different ones. Let's call this preprocess.py. So if you want a preprocessing function, you can specify that here. But for our purposes, we're not going to use this, but just to break this down, code blocks in the worklet will take in a block input, an environment, and a context. So these are all things that, yeah, I guess they're here in the docstring. So it's a JSON serializable block, a dictionary to this function. The environment is another dictionary that holds state as it goes through different blocks in this worklet. So if we have like many of these, the environment will kind of serve as like a steady state for all of the things that we do in here. And then context has different helper methods for data access. So things like data integrations to whatever data store your company or that you personally use can be accessed here through this context variable. And you can see the docs for more information on all of these sorts of things. And it expects as the return type another JSON serializable dict, which, if you think about it, we can again propagate through our DAG. Okay, so again, for us, we're not going to need this sort of functionality around our model. The model itself is just enough. So we can go here. Yeah, and from here, I think we're actually kind of good to go. So remember that we didn't bind anything to these text boxes. They're just placeholders. But let's say like we forgot the output of our model and how that's formatted. We can look at like the different logs that this application will give us. So this is kind of exposing a lot of observability for our user, and just letting them see like what's going on, what's going wrong with their application. So we can go ahead and just start recording a section of our voice. There's a really cool, kind of simple audio visualizer, which is a nice touch. And once we're satisfied with the sample that we are uploading, we can go ahead and stop. Awesome. So you can see here even that we have a state setting. So we changed this button disabled to false. So now we can actually go ahead and click on our button. So again, to remind you what we're doing, we're passing the URL of the microphone recording to our worklet to be run. And then that's going to be saved here. Okay, so let's transcribe. Awesome. So our worklet run succeeded, which means that our model also succeeded. And what we can do is we can actually go ahead and pass the output of that worklet, yes, with the autocomplete as well of our model output. And then let's put our detected language there. So our model detected the language English. Good start. And let's put the text that we have there. If we want to check this transcription based on the audio playback, we can use the microphone component built in. So we can go ahead and just start recording a section of our voice. There's a really cool, kind of simple audio visualizer, which is a nice touch. And once we're satisfied with the sample that we are uploading, we can go ahead and stop. Word for word. Very great job, folks behind Whisper. Yeah, so end to end, not all that long. Hopefully you can kind of see the value that Truss and Baseten and that sort of pipeline brings to machine learning apps, where you can bring them directly from academic teams and publish an app with full ML infra stand-up behind it in a matter of minutes. So yeah, thanks for listening. And you can check out the demo that we will have up soon.